look at in paper 1. Okay, these are must to come topics. We have bearings, circle theorem, graph, parabola, inverse and composite functions, variation, linear inequalities, travel graphs. These are must to come topics. And of course, we're going to concentrate on these for now. There are about 7 topics. Once we do away with these, we cover them nicely. I'll give you questions, then we'll shift our attention to other topics so that we're done with paper 1. Once we do that, I can assure you it will be very easy as we tackle some of the questions in paper 2. Then you'll be set. And by that time, I'll have actually made you ready for your exam, GCE or indeed internal. All right. Highlights in circle theorem. We did look at a number of theorems. It doesn't matter the order. Theorem number 1, 2, 3, 4, 5 doesn't matter. What we did, I'm just going to remind you. We did look at theorem number 1. Theorem number 1. We had something like, we did talk about a circle. We did mention that the boundaries of this circle is actually what we call the circumference. And apart from that one, we did also say that this circle has got a center denoted by O. Take note. Apart from that one, we did also talk about the diameter. So you can have the diameter, which is a line across the circle that passes through the center. That is what we call the diameter. Now, theorem number 1, it states that this diameter is capable of dividing this circle into 2 equal halves. And these halves are called the semicircles. Take note. Semi means half. So this is a semicircle and another semicircle. Take note, this is the diameter here. Apart from that one, we did mention that one of the theorems indicates that if suppose we are concentrating on this upper region or the semicircle, any angle that will be produced in this semicircle by this chord, this major chord, it will actually equal to 90 degrees. That's what we mentioned. Take note, if you have got a chord, any angle that will be formed in that semicircle, that will actually equal to 90 degrees. That's one of the theorems that we did look at. Quite interesting, right? And of course, we went further and we looked at the theorem number 2, where we did mention something like, if you have got something like this, then suppose we have a sector. A sector is a region surrounded by 2 radii in the arc. So this is the arc, and these are the 2 radii. These 2 radii are equal lengths. Take note. So here we've got 2 sectors. We've got the minor sector, which we're able to see, this region here, and the other, major region. We did mention that I've got 2 regions here. There's this one which we're able to see here, and of course this bigger one there. So these regions are referred to as these sectors. So this is a minor because it is small, and this is major because it is big. Now, with reference to the angle formed at the center in the minor sector, we see that this arc, this small arc here which you are seeing, this small arc or minor arc, is producing the angle at the center. So they are saying the angle that is produced by this minor arc at the center is 2 times bigger than any angle that the same arc will make, okay, in the major sector at the circumference. That's what he said. This simply means that if the angle formed in the minor sector it is 40 degrees, it simply means that the angle that will be produced at the circumference, it will be half of this angle. And the half of this angle, is 20. That's what we did look at. That is theorem number 2. Please never forget. And the same scenario, this is scenario number 1. On the same theorem number 2, angle at center is twice angle at the circumference, or angle at the circumference is half of the angle at the center. Take note. That this is scenario number 1. Take note. Let's look at scenario number 2. Observe. Scenario number 2 on the same theorem, we're going to have this. Then this time around, we have got this. This is the sector. Observe. Now what happens here is this. Let's talk about this angle here. This angle is actually in the major sector. The angle produced in the major sector. So this angle will be twice the angle that will be produced in the minor sector at the circumference. For example, if we produce any angle in the minor sector here, it will be half of which angle of this angle. That is scenario number 2. So this is scenario number 1 and number 2, and this of course was scenario number 1. Okay, so please never forget. If you have got this, never forget. Then of course we also have scenario number 3. Okay, where you have the circle like this. Now this circle has a diameter. Then it so happens that we have, as you may be able to see here, we have got 2 sectors. We've got this sector and this sector. This is a sector as well. Yes, did you know? Because the sector, the definition is any region surrounded by 2 radii. And you see from here to here, this is 1 radius. And then from here to here is another radius. But of course, we also have the arc. All the way around up here is another arc. So this arc plus these 2 radii, despite them being on a straight line, or despite these radii making up a diameter, this in itself is also referred to as a sector. Take note by definition. Now, it also happens that we can also use the same principle number 2 or theory number 2, where we say the angle, if we take for example the angle at the center, this angle here, suppose we take this angle here, this angle, we see that it is 180 degrees. Okay? It's 180 degrees. Now, this angle at the center will be twice in angle that will be produced inside this sector or semicircle. Check it out. So you see that this angle will be half of this particular angle, and ultimately this will be 90 degrees. Are you seeing? And we are seeing the combination of this one, which is true. So this and this theory number 2 are related actually. Check note, and the same will be true if this angle here. This angle here will be twice the angle that we produce. So just opposite. Okay, this angle is for any angle that we produce in the other semicircle, and this is 90. Follow the idea of the theory number 2. That is it about theory number 2. All right, let's progress and see other theorems. We also did mention that we have other theorems, the number of theorems. We did mention that we can have a circle like this, and in this circle we can have a 4-sided polygon referred to as a quadrilateral. A 4-sided polygon, a quadrilateral, check note, and we are seeing that its corners are referred to as the vertices. So these vertices, they are right on the circumference of this particular circle. Such a quadrilateral is referred to as a cyclic quadrilateral. Check out. Cyclic quadrilateral. Check out. Very important.
we did mention also further to say the opposite angles in a side equilateral, they add up to, the sum of the opposite angles in a quadrilateral, they add up to 180. They are said to be supplementary angles. And the sum will be show of this one, if this is A, plus this one here, they'll give you 180. That's the principle. So if you know one, it's easy to get the other one. You know one, but the other one is not known, you simply subtract the known from 180 so that you get the unknown. Simple, right? So the idea here is x plus y, and for x plus angle y will give you 180. And the same is true of angle A plus angle B will also equal to 180. That was one of the theorems there. Anyway, I'll name it theorem number 3. This will be theorem number 4. Okay, like I mentioned, the order does not matter. If they don't have specific numbers, they are not glued to those numbers 1 into, so never memorize. So I couldn't remember theorem number, don't. The idea is just to know what is actually happening. So if I want, I can bring theorem number 80 as our first theorem. It doesn't matter. So the number, it doesn't matter. Okay? Check what it is. So I can stop with theorem number 3. If you go on theorem number 3, that's what actually what we see. Let's move on to theorem number 4. Theorem number 4, I could bring something like a circle. Now this time around, I have, a four-sided polygon once again, which is a quadrilateral, but something is special in this one. Because what we are seeing actually is that we have the exterior angle take note. So this exterior angle will actually be equal to the interior opposite angle. So the opposite angle of this is actually this one. So this angle here will be equal to the exterior opposite angle of the side quadrilateral. So x will actually equal to y. Take note. Okay, that's what we did look at that. And of course, the same principle of the side quadrilateral actually here applies. That's what we did look at. We went further and we did also observe that we had another theorem. Okay. We did also mention about the tangent. Remember, we did talk about another theorem. Say theorem number 5. We had another theorem number 5. Remember that this theorem is talking about the tangent to a circle. The tangent to a circle, we know, is any line that touches a circle at one point. So if you put this is what we call a tangent. Please never forget. And of course, suppose this tangent meets with the radius of this particular circle. There is a certain angle that these two lines actually produce. That angle is equals to 90 degrees. Please never forget such. Never forget such. Okay. Apart from that one, we have theorem number 6, where we mentioned about a circle. Now this time around, we have got any two tangents. These two tangents, they are meeting from the external point. These two tangents are meeting from the external point. Take note. So this is the tangent. Observe. This is the tangent. So we are saying, we learned that, the lengths of these tangents from here to here, and from here where that is the circle to here, these lengths are equal. These lengths are actually equal. That's what we meant. And this is true. So each time you see such, look out for such. If at the same time, suppose we have a tangent, the radius, okay, that intersects this tangent here, automatically will be 90 degrees here. And also on the other side here, suppose we have another radius here, we see that this radius and this tangent are making up a 90 degrees angle. This is very, very important. And so we see that this is the only special case or situation where the properties of the cyclic quadrilateral in terms of the angles, the opposite angles, applies. We see that the angle produced by the intersection of the two tangents externally, this external angle here produced by these two tangents, okay, plus the angle at the center of the circle. These two angles are said to be supplementary. They add up to 180 following this particular theorem. And the same is true of this corner or this angle and this other angle. If you add these two angles, you get 180. So please take note and try to appreciate this. And the last theorem that we did look at, I'll say the seventh one, is actually something that I'll just write maybe just somewhere here. I'll say theorem number 7 and the last one. We did mention that. We talked about the alternate segment where we have a circle like this, for example. In it, we happen to have any line across. We don't know whether it's a chord, it could be a chord or any other. It could be a major chord or a diameter or any other. Okay? So you see that this chord divides this circle into two segments. We have got this portion of region as a segment and another one as a segment. Now, we did mention that suppose this chord intersects with a tangent. It could be, this is a tangent there. We see that the angle, made by the tangent and the chord is referred to as the exterior angle. Okay? Exterior angle, take note. This is the exterior angle. So this exterior angle, take note, will actually be equal to any angle that will be produced. In other words, this exterior angle is actually produced in this segment. If it's produced in this segment, then this exterior angle will actually be equal to any angle that will be produced in the other segment. Okay? So for example, in this other segment, we could have another angle like this. This segment here is producing this particular angle. This angle and this exterior angle must be equal. That's the idea. If this is 100 degrees, this will also be 100 degrees. That's the idea. We did look at this. These are called alternate segments. Alternate means, opposite. Alternate or alternates. That's the idea. So if you're talking about this angle here, this angle will be equal to any angle that will be produced in the other segment. If this angle were to be this side, suppose we are to extend this particular, tangent like this, then we're going to have this as our external or rather exterior, angle. Okay? This exterior angle will now be equal to any angle that will be produced in this segment here. If this is 98, so will be this one. That's the idea. Okay, we did actually talk about this one. And this actually marked the end of all the theorems that we did look at in Circle Theorem. Quite interesting. All right.